Hi there, welcome to my channel, and on today's topic I'm touching on construction joints. To make this clear, many of us in the industry assume that the construction joint is always at 1/3. To cut the long story short, I've come up with this example to showcase what kind of considerations ought to be taken by the contractor, engineer, or anyone in preparing the shop drawings or construction joints, marked up drawings for the site to execute. Firstly, you can see that I've shown here one-way span slabs supported by beams. Oops, I'll just switch on the marker here and highlight it as I go along. Supported by beams here, and at the bottom here I have the free body diagram for bending moment and shear force. For those who are not familiar, you will have to eventually, with lots of practice, you'll understand how to do the free body diagram. However, coming back to this topic, I'll save that for another topic. Coming back to this topic, you would be able to see how this bending moment and shear force envelope is drawn for the continuous beam. Make note that the sagging moment for the end span, which is here and here, is larger than the sagging moment for the internal span, and shear force is largest for the internal spans as compared to the end span. Now, taking you one step further, I've divided this into internal span, where I'm going to zoom in, and also to the end span. Here you can see on the internal span, I've marked up the intersection points to show where the bending moment intersects with the beam on the x-axis, which is here and here. So these are the points of contraflexure. That's where bending moment is 0. Now shear force is 0 at this point, which is y. Now going to the end span, you will see that the bending moment intersects here and shear force intersects here. What many would do is they would literally go and assume that the construction joint is at 1/3, which is here. It's not a bad thumb rule, but it should be applied very carefully. So you can't just assume. Looking at this, the best place to actually apply a CJ or a construction joint would be in between here and here. Similarly, for the end span, it would be from here to here. Why is it so? Reason is because the bending moment is at 0 here, and shear force is at 0 here, and the maximum bending moment would fall outside in a way. So anything that is here will be ideal. I'm just going to mark as a cross. I've come up with another example just to show you how you should consider doing up a construction joint. Now, contractors will usually cast their beam first and then followed by their slab. And so, in consideration for the beam, you'll notice that you'll have beams along here internally as well as at the end. So typically the bending moment in shear force would be something like this for the simply supported, and continuous something like this. Similarly for the slab, of the same arrangement as above, for the slab element, the shear force and beam bending moment, would be like this. So you can see similarities between the beam and slab, which is this and this. You must understand, I'll use a green color highlight, that the main reinforcement for the slab spans this way. Yeah, this is just the same as above, and the secondary is reinforcement spans this way. Okay, so applying a construction joint, the best location for this situation would be, if I were to do it, I would not do it at mid-span. Why? Because of high bending moment. I may do it at 1/3. Why? Because it's lesser, bending moment is lesser over here, and shear force is somewhat in between the max and where it's 0 over here. So taking it 1/3 wouldn't be a bad idea. However, in some cases, depending on the engineer and how your reinforcement arrangement is, the consultant may agree for you to apply a construction joint over here. But I would not advise for it to be applied there. Reason is, a construction joint is an induced weak point somehow, and that is the location of maximum shear. So finally, I would say the best construction joint location would be here. So I hope you get the picture now, and you must understand that construction joints, apart from just the point of contraflexure and zero shear, another factor which you have to consider would be, in determining this construction joint, would be the logistics on site, whether the consultant designed it as a T-beam, L-beam or rectangular beam. Because if it's T-beam or L-shaped beam, it's going to take up a chunk of the slab in terms of the design analysis, and so inducing the construction joint for the slab and beam, you would have to have it coincide. Unlike a rectangular beam, where you may have the construction joint slightly different from where the slab construction joint is, depending on site. But however, it is always best practice to have the CJ coincide with the beam and slab. So I hope this basically gives you an idea that it's not always the case at 1/3 of the span, or some of them would say the middle third of the span. We just do not want to put the construction joint where bending moment is maximum and where shear force is maximum, but somewhere in between. So I hope you like this video, and it's my first video, so I'm just giving it a try, and I'll come up with more topics. So if you do like my channel,